Okay, so yeah, today we're gonna talk a bit about um, some of the emerging technologies we're seeing and their role in preventing MSIs. I'm going to introduce a couple of these technologies and talk a bit about some of our learnings from the different projects we have had, looking at applications, case studies, collaborations with researchers and different organizations. So some of you might have seen this document by the National Safety Council on how new and emerging technologies can transform the ways we assess and prevent MSIs. Maybe you've heard a bit about some of them, more about some, not as much about the others. Again, I'll be introducing some and talking about what we've been seeing in terms of their application. I will be going over the content fairly quick and won't really be able to go really deep into any of these for the sake of time, but would definitely be happy to connect to anyone who likes to dive a bit deeper into any. So I'm going to talk first about exoskeletons, and then I'm going to touch on the use of computer vision and wearable sensors, and then extended reality. So industrial exoskeletons or occupational exoskeletons, I'm going to start with that first. Exoskeletons, exosuits, wearable robots, different names, same concept. The idea is to reduce the loads on the human body and basically augment the user's performance. A bit of history on them. Started around 1965. GE had a exoskeleton called the Hardyman. Ended up being too heavy, too complicated to use, didn't really work out. But later on, we saw a lot in applications for gait assistance, for rehab type of applications, of course, military. And then around 2015 and 16 is where we started seeing commercial, industrial, or occupational exoskeletons, which is basically our main focus. In terms of the types, there are powered or active ones, and then there are unpowered or passive ones. And more recently, we're seeing more soft exoskeletons being introduced. So active ones are the ones that there is an external power source. There are usually sensors, actuators associated with them. And passive ones is where you don't really have an external power source, and they use spring systems, shock absorbers, things like that, bands to augment the user's strength. So with the active ones, they can potentially reduce the amount of strain more than the passive ones, but they're often bulkier, heavier, more expensive compared to the passive and soft ones. You have to be aware of battery issues, charging, things like that. Whereas the passive ones, especially the soft ones, are lighter, cheaper, usually have a larger range of motion. Again, although they might not be as powerful in some cases. But what we found is typically for use in industrial applications, passive ones are the ways to go, at least based on what's now in the market. And there's really good opportunity for soft ones because they're portable, they're lighter than even passive ones. They can be cheaper as well. So exoskeletons can support different body parts, or in some cases, use a couple of them together to support more than one body part. Back support exoskeletons are one of the primary ones we see in industrial applications. The idea is to take the load from the lower back, which is not a very strong muscle, and reduce it, transfer it sometimes, or parts of it sometimes, to stronger muscles such as the legs to support any sort of manual material handling. Shoulder ones for any type of activity happening above head, above shoulder level, basically holding the arm for the user. There are leg ones as well, like support exoskeletons, not used as often, but if you have cases where there are specific postures that are held for sustained periods such as this, and you want to transfer basically the load from the legs, from the knees to the ground, they can be used. There are also ones for arm, hand. There's a thumb one. There are ones for neck, but they're basically a bit more simple than the back and shoulder, and not used as often. And as I said, with some of the brands, you can basically use them together. So have the exoskeleton that supports the shoulder and also the one that supports the back, and use them together. You have to, it has to be a very specific application where you want to do that. So not very often, but it's an option. There are also tool holder ones where if you have heavier tools that the workers are using for a longer amount of time, they can be used. We're not seeing them as frequently used because of issues with balance and things like that, but just be aware that there are ones available. In terms of applications, as I mentioned, medical and rehab is a big domain, military, industrial, and then more recently, there are ones for personal use, fitness, sports. There are ones for skiing, for example, and I believe we're going to see more of those as well. Once in a while, you might see something like this, and people assume that there is a special application for this, whereas it's basically entertainment, so doesn't do really anything more. There's also an important discussion in terms of where do these fit in the hierarchy of controls, and some would argue that they're just a form of PPE. Some would say they're an engineering control. Some would say it's just another tool. Some believe it should not be considered PPE because then you might just hand them off to the workers and expect them to work, but it's not really that type of device, and you need a proper evaluation implementation plan. Others would argue that it should be considered a form of PPE because then you're going to think about your other engineering controls before defaulting to exoskeletons. In any case, the important thing is to consider all your controls and their feasibility before leaning towards something like exoskeletons. The adoption of industrial exoskeletons has been primarily in manufacturing and automotive industries, and that's mostly due to the cyclic nature of the tasks there and their predictability compared to some other industries. And some good progress has been made. For example, Toyota is now requiring exoskeletons as PPE, so they're kind of like mandatory in some of their plants and some parts of those plants, some of the tasks that is happening there. And those are, for example, if you have a worker working 80% of the time on their car, having their arms above shoulder level, it makes a lot of sense. So they've done that. Standards are being developed more and more, which are, again, an important piece of the adoption. A lot of our work is going beyond these industries, looking into heavy industries, construction, steel fabrication, utilities, things like that, where you have less of that predictability, more dynamic tasks, more challenging to adopt something like this, and really finding ways to implement them. So an important part of the discussion on this technology is still the research and development. And when I talk about research here, I'm not talking about research done just in university labs. I'm talking about collaborative research where these are taken into fields. And that's one of the things we were doing, working with industry and researchers and taking them to fields and putting these suits on workers and really going through that evaluation and adoption process. So the research and development piece is basically in 3 domains. One is the development, design and development. Most of these devices, or I should say a lot of them, come out of university labs. So you have prototypes, they need to be designed and developed. Next domain is the evaluation. So we have these, and then how do we evaluate if they're doing what they're supposed to do? For that, we usually use objective measures where we start looking into muscle activity, motion, sometimes heart rate and things of that nature. And then also subjective methods, which are as important, if not more important, to look at how the user feels in terms of their fatigue levels, discomfort, generally speaking, the usability piece. There's also a third domain, which is the adoption. So we know these devices are out there. We have evaluated them. We believe they work for our application. How do we really go about the adoption? What's that process look like? So because of all these different factors, these different components, as I said, there's still the need for that step that it's more of an evaluation stage, more of a R&D type of work to make sure that you go through that process, through the adoption process really effectively. I'll quickly touch on some of our work in the past few years. Obviously, I'm not going to go through details. There are publications on all these that people can read, or I'll be happy to connect and go through. But just to show you the type of things that we start thinking about. So one of the things when we first started looking at these technologies was we had a back support exoskeleton, a passive one. And some of the questions were, how is it going to impact basically how the performance is going to change if I have different postures? So I'm stooping versus squatting, or if I have different genders using it, or if I have dynamic manual material handling versus static ones. So we started developing scenarios to test those, had subjects, and did a couple of experiments. So basically the type of things that we looked at was their fatigue levels after doing the task without the exoskeleton, with the exoskeleton, with different postures. And we looked at things like how comfortable do they feel the suit is, how much do they feel it limits them, how much do they feel it interferes with the things they're doing, how would they rate the overall effectiveness, and also discomfort. Where are they seeing discomfort? How would they rate that? Also, as I said, comparing static and dynamic scenarios, looking at the same factors, comparing male and female in terms of their fatigue levels, discomfort levels, and those effectiveness and comfort factors. So a lot of details and charts and everything that again can be found in the publications, but it really showed us that you have to look at all those different factors and focus on the task at hand. So you want to look at the how the task is being done, who's doing it, what posture are they using it. For example, one of the things we found is if you're doing a sustained task, sustained posture, basically static task, and you're using a squatting posture, sometimes it can actually make it harder because it's pushing you back. This specific brand had a chest piece, so it could push you back and it would be hard to keep balance, or basically it would put more loads on the legs because it's taking the load off the back, but in those postures it would put it on the legs. So again, a lot of details that kind of highlighted to us that you have to look at all those different factors associated with the task. So as a next step, we took it out to the field. This case was for utilities and maintenance and handling manhole covers. So we started looking into the use of exoskeleton because there was a lot of discomfort and injuries associated with the task. These covers are heavy, and some of the crew who handled them can do 40 or something, a really large number of these per day. So we started also adding those objective measures that I talked about. We looked at muscle activity and using EMG sensors, motion analysis, IMU sensors, obviously in addition to the subjective measurements. So in this case, they were handling those manhole covers either through a manual method, that upper left picture, or using that what was called a Jake tool, upper right, or an in-house lever tool, basically. So we really want to look at what's the effective way of doing it, and does the exoskeleton help or not. So we always kind of start the experiments by designing them in labs. So we did that in the lab, make sure the process is all worked out. We have all the details, we know what we're measuring. And then we took it out to the field. In this case, with 20 subjects who were the actual workers who carried out the task. So we did those measurements, but also asked the questions on the discomfort. Do they feel things like skin irritation? How does the fatigue level look like? Do they feel that it's restricting the ability to work, walk, move freely, and overall comfort level? So for those three methods, one of the things is we compared no exoskeleton and exoskeleton and looked at muscle activity and how it's impacting that. So in all cases, it improved, especially in the lower back, which was our focus. Most improvement was seen using the Jake tool, which is shown on the right, which was one of the concerns that they traditionally used that tool, but they were seeing a lot of back injuries. So we looked at the use of the exoskeleton, but we also wanted to know that something like that lever tool, which gives them a better posture, less force to apply, so it's a safer method. How does that compare with the Jake tool and the exoskeleton, right? So looking at all the combinations, because our goal is to solve a problem, not necessarily validate the use of exoskeleton. So again, we found that using the lever tool was still keeping in that safe zone. So it's basically the best option. But if you have to use the Jake tool, use it with the exoskeleton. But if that lever tool is available, you don't really even need the exoskeleton. So muscle activity, things like posture, scores, and how do these different methods compare, subjective feedback, the difficulty with the task without the exoskeleton, their pain levels, looking into where those discomforts are, how are they changing? And these are examples where you can see the load on the lower back decreased, but for instance, with the Jake tool, with a specific exoskeleton, they felt some discomfort in the chest and on the thigh because of the pads that it had. So again, all the details that you have to go through. Again, there was a bit of detailed findings, but we're able to find which tool was the best. Most participants felt that the exoskeleton did actually help reduce the load on the body. Fit, we found, is really important. And then some of the details that I might get back to later. Next, we took it out to steel fabrication because we had welders who would go into these sustained postures for long times, and usually all of them have some sort of lower back discomfort and pain. So we started fitting them, and this is ongoing work. We started fitting them with exoskeletons. Again, went through some of the subjective feedback, comfort level, restriction, the support they're getting, even things like the productivity, the task completion time. If they feel any skin sensation, if they think the weight is appropriate, the social perception, does it make them feel bad or good? Do they like even the material and the design? And really, we learned that we have to get deep into the subjective feedback, because at the end of the day, it's what is gonna determine if the worker is gonna use this or not. And it's not necessarily just the measurements, just subjective feedback. It's this type of feedback. And what's interesting that what we see is you get feedback like, I feel real safe, I can feel the support, my back usually hurts, but this time it didn't hurt after I used this. So this is the type of thing you want to hear, right? So it's helpful. Then you have feedback that, it's kind of more suspicious, only in some cases I'll use it, or for some tasks. And then there are ones that are not as positive. I felt it was bulky or heavy. It won't last in the shop. I don't know how I can get out of it in case of an emergency. It was complicated. It was uncomfortable, or it wasn't useful for welding. And really, the question here is: this is the same organization, same task, same location, just two different workers, and one of them thinks this is really good for welding, one believes it's not. So what is causing that? That's really the essence of what we try to get into. Also, as I said, the adoption piece is really important. So what are all those steps that as an organization you need to take to evaluate, implement, monitor these, from the feasibility assessment all the way to a trial and the long-term adoption? So that was also another thing that we'd worked on, because we realized that there's a gap there as well. Some companies see the opportunity and it might be the good fit, but they don't do the adoption process effectively and it fails. So quickly, some very high-level observations and findings. As I said, we always need to look at the task. Adoption needs to be task-based. Passive exoskeletons are the type to go for now, especially if you have soft ones, based on what's available in the market. Some existing ones are not designed for some industries. So if you have special tool belts or clothing or some sort of PPE, again, you want to make sure that you evaluate what you're using. Does it fit properly? And you have to go through that selection process. Again, stressing that a lot of work has focused on those objective measures, muscle activity, range of motion, but the adoption challenges, things that relate to how does the worker really feel about it in terms of comfort, fit, heat, and as an organization, how do you adopt it? Those could be the more important pieces. Also, a lot of work has focused on very short-term studies, so long-term adoption are needed. We are using them, for example, in welding for whole day, whole shifts, just to make sure it reflects real conditions. We're getting them to do their normal jobs, plus some that we ask to specifically measure things, but that's also a piece that's needed. Again, you need a solid plan in terms of who does what, when things happen, how do you communicate it, just to make sure it works properly. Sometimes one of the things I see, especially when managers and executives try these on and they see how they support, because it's always different when you put it on and you feel it, they get excited. And that's good, because then they're open to piloting, testing, there's buy-in. But sometimes it can cause unrealistic expectations, and it might cause them to not go through that hierarchy of controls and think this is going to solve their problems. And one of those expectations can be that now they can lift over limits, over that 50-pound limit. And I've seen that both from executives and workers, which again, you want to make sure those things don't happen. Training is critical. How do you train people on the use of posture? We saw the people use different postures doing a task. So now you add exoskeleton, add complexity. You have to be sure you train them properly in the use of it. So I'm just gonna shift gears a bit, jump to the computer vision and wearables technology and talk about that a bit. And obviously at the end, we can go through questions about all. So when we look at computer vision wearables, we're talking about motion capture, basically recording human movements. You probably have seen the applications in things like movies, animations, but a lot of different applications too. But it also lets us look at human movement from the ergonomics and biomechanics perspective. And when we talk about motion capture technologies, there are marker-based systems, which you have markers on the body, and then you have a bunch of cameras around. The Vicon system is an example of one of those. Then you have wearable sensors. They're usually IMU sensors, where you put a couple of them on the body, strap them, or integrate them into clothing, and then monitor the movements. Or they're vision-based systems. That's where most of our focus is, just because the ease of use of it and the opportunities that it brings, where you just have a video recording and you're trying to do the analysis on that video recording. So why do we even look at this technology? Traditionally, you had an ergonomist for health and safety professional look at a task being happened, sometimes doing measurements in field or looking at videos, trying to find those angle ranges and postures and come up with scores. And basically the technology is trying to automate that process. So in terms of cost, this automation can reduce the cost associated with the risk assessment in terms of time, can save a lot of time compared with the manual way of assessing risk. It gives us the option to complete remote assessments. So you don't really have to have experts on site. Access, instead of pen and paper or having reports on your computer, everything can be stored and accessed easily at the same place. Complexity, really the tools that can be integrated into these systems, the user doesn't need to have that detailed knowledge of how it works, if it's a screening system or an assessment tool. And then reliability, there are studies, and I'll show some of that, we're not as accurate as a system in terms of finding those angles and categorizing them because of a natural human error. So when we talk about vision-based motion capture, basically the idea is there's a video recording, and in the frame of a video, we use a bunch of algorithms to get to those joint angles and position of different body parts. So first we detect the person, or the people in the video. Then we find the different parts of the body, kind of building that skeleton. Then we do what we call 3D lifting to really change this 2D view to a 3D model where those angles are more accurately represented. And then based on that position of each joint angle, we can get into things like the risk structure of associated with the task. So basically looking at joint angles, we can start defining thresholds. When am I in the safe zone? When am I in the caution zone? When am I unsafe? And jump to those points where it's unsafe for different body parts and see how we can change to make it within the safe limits. There is a comparison between vision-based and wearable sensors. Again, I'm not going to talk about it a lot, but basically, you can look at the cost, the time, the ease of use, complexity. Vision-based because you're just dealing with a video recording that can be done on a phone or any smartphone, any camera. It's a lot less complicated or time-consuming or expensive. If you want to have a very long duration, a whole shift for 8 hours, maybe not as ideal because it's really hard to handle a very large file, a video file, right? So those are cases where wearables might do better. If precision, meaning the exact values of joint angles are of importance, wearables can be a bit more precise. But again, you're disrupting work. You're basically putting something on the workers. So again, if you have PPE, or in our cases, when we're using exoskeletons, there is a bit of interference. One of the studies that we did with the University of Alberta was really comparing the technologies and also with human evaluation. And that was through doing much of experiments, fitting people with these wearable sensors, and also running the analysis through the video, and also asking humans to give us feedback. We did this in lab, in field. Basically, the idea was you have tasks like this where we compared for different body joints, what does it look like, the angle estimates for the two systems. And then, for different frames, if we ask for human feedback, and in this case, it was, this is shown as an average of 6 professionals, how would they estimate an angle value for different joints and compare it with what the system gives us, the wearable system, and then the vision-based system, which ours is called PostChecker. How does it perform? Which was interesting, as you can read through some of the numbers. The two systems were pretty close, but the human estimates a lot of times were pretty off. And if you were doing some assessment scoring system like a REBA, we'd get same score for the two systems, even though the angles are not exactly the same. But with humans, you can get different scores. So again, a lot of different types of postures, looking into different joint angles. Sometimes we would see that the difference goes even up to 40 degrees of difference between what the human would estimate and what the systems would give, but the two systems are still fairly close, even in cases with the vision system that we have. Even in cases where we can't really see some body joints, we could still give some pretty reliable estimates of the body joint. So this is what basically a system like this would look like. You take a video of a subject performing a task, preferably not very long because it gets large. You have options when you're uploading it, where you can blur the face for privacy reasons, you can blur the background, or you can indicate if you have multiple subjects, you can tag it for grouping and stuff. And then once it's analyzed, after a few minutes, this is what you see. The video superimposed with the skeleton that's color-coded, along with the body chart. And also for each body joint, you can see that profile of where am I in the safe zones, and you can quickly jump to different points of time and see, okay, what's happening here that I'm seeing a lot of risky postures or joint angles, and how can I fix that? For the different body parts, you can quickly get a summary of what's happening, what percentage of time are you in safe or caution or unsafe zones, and where is your priority basically. So I have to focus on the back or the neck and redesign task. You can do comparisons, side-by-side comparisons, where you can look at two people doing the same task or same person doing the task with two different methods, and really compare them. Great for before after interventions type of thing. Also, you can do different types of assessments. So for example, the REBA assessment, you select your frame, the system autofills your variables, you can change anything you want, and then you can store that scoring and attach it to that video or that task. So again, enables building that assessment. In terms of assessment or applications, some of the things we have realized is when we deal with clients and organizations and professionals using this system, that really helps with decision making. When you visualize it, it's easier, especially for the managers, to see the risks and really feel like, okay, I see what's happening. What do we need to do? So they understand the risks, they're more engaged and willing to make the changes. Also for training and behavior change, when you're training workers, supervisors, when you visualize the problem, it's really becomes a lot easier to visualize the solution as well, right? To justify why we need to change. And really it gives them that aha moment when it's like, oh, I see what's happening, so I need to change this and that. Also comparisons, as I said, we've really seen that people like that because it enables to really effectively evaluate interventions. So we've used it in various sectors and industries, manufacturing, construction, utilities, continuing care, operating rooms with surgeons, healthcare, and some of the things we've learned speeds up the assessment a lot for a safety professional, reduces time, cost for travel. A lot of times you don't need to be there. Visualization, if someone is not familiar with MSDs or how you assess them, helps a lot with that visualization, especially when talking about supervisors, frontline staff. AI ethics, data privacy are important because these are AI systems. So you always have to be aware taking people's videos. And that's why we have things like blurring the face or background and things like that. And we'll always make sure that we're using secure servers and things of that, but you have to be aware of those. As I said, before and after videos, people find that useful. And one of the things I always say is these systems work best when they're complemented by a professional, because the system is really good for data collection, but you still need a professional to talk about the interventions, think about the recommendations, and the tool helps you identify what needs to be fixed, but you need that trained professional to tell you how to fix it. So again, it's not replacing that role of that professional, it's just complementing, it's just making it easier for them. So I'm going to jump to the extended reality technology now. Extended reality is basically an umbrella term that's used to cover 3 different technologies: virtual reality or VR, augmented reality, AR, or mixed reality and MR. Virtual reality is basically where you have a fully immersive digital environment. Augmented reality is where you have a view of the real world, the physical world, with an overlay of digital elements. And mixed reality is basically both. It's when you have a view of the real world, the physical world, with an overlay of the digital elements, where these 2 elements, the physical and digital, can interact. So you can shift things around and play around. So in terms of health and safety, it has good potential for training. You can train people in a safe, controlled environment. You can train them on protocols. You can show them different scenarios, get them to select scenarios and see what happens as a result. For hazard IDs, very useful, and it can has potentially better retention as well for the workers. You can simulate different environments, especially the hazardous ones, high-risk scenarios. You're not putting people in danger, but they can see the impact of their decisions and how different scenarios work. And you can also, with things like augmented reality, you can provide real-time data, right? So they can have a phone or a tablet or device that they point to different things and they get information about what's happening, any hazards. One of the things that we did was we started pilot the technology for training officer ergonomics. So we had a 2-day training that we've had for a long time that basically trains people on officer ergonomics. And the first day of that is basically just training. The second day was hands-on training. And with COVID, we couldn't do that in person. So it was challenging to do that second day hands-on piece in person, and virtually it would be hard to do using just slides, right? So we worked on this VR experiment where, as you can see, they could interact with the system and see the system update. So this was an office ergonomics. We defined different scenarios. This was home office, basically. Again, you can see the environment, the user needs to interact, say, okay, I see there's a footrest needed. And when they select that, they see that change. The monitor needs to be higher, so you can add a monitor stand and see the model change. And that's the beauty of these systems. Again, a sit-down workstation, so apparently the work surface needs to be higher, so you let them change that and see that change in real time and how it's impacting that office workers' posture and everything, and getting feedback on, okay, this is good, or you need to do anything else. Again, add a monitor stand and then things like that. Or if you're selecting the wrong thing, giving feedback why it's not correct. So again, really helped us understand the value of this type of technology. And in this case, it wasn't only on the VR headset, it was on a computer as well, because they said some people were remote, so they could do the whole thing on their computer with just an access to a link, a web-based system. One of the things we did after this is we got user feedback, because again, it was important for us to see how people feel about it. So we asked them about whether they felt it improved their ergonomics knowledge, whether they recommend the use of it as a supplementary tool, whether they think it should replace part of the course, and specifically that second day that I talked about, the hands-on day, should it replace that? Because one of the things we did is we had some groups that we did both, the in-person and this virtual format, and then we got that feedback from them as a comparison. The results were interesting in terms of liking the VR system. Most of them liked it. The average score is 4 out of 5, so they felt it improved their knowledge. Even higher rating for recommending the use of it as a supplementary tool, 4.5 out of 5. A bit less in terms of replacing a part of the course, around 3, and also in terms of replacing that second day of the course, around 2, which was really interesting. And then these results and the feedback we got really showed that people like this technology, like the use of it, but as a supplementary tool, not to replace an in-person element if you can do it, right? So they believe it helps solidify their learnings. They like that it gives you an independent practice time. You know, some people need more time because this was a group training, so it enabled them to take their time. It shared feedback. They like that. You can practice multiple times. You can practice different scenarios, so they like that. But at the same time, most of them didn't want it to fully replace that hands-on in-person element, because you can ask questions, or it's just not as good. So that was on the extended reality application side of things. So basically, I want to kind of close with some of the challenges that I'm seeing in terms of adoption of emerging technologies for health and safety. The top ones that I see out there. One is obviously the cost. Implementing new technologies can be expensive. It can require especially significant upfront investment in specialized equipment, the software, personnel training, and this can be a big barrier for smaller companies or those with limited budgets. Resistance to change is another one. Some companies or professionals might have a bit of resistance to change, particularly if they're accustomed to the traditional methods, or basically see these new technologies as being too complex or too disruptive. Technical limitations. Some of these technologies might not be fully developed or may have some limitations, which can impact the quality, the effectiveness. and limit their potential applications. So that's another thing that you have to, especially reliability and safety can be critical. So you have to make sure of that. Lack of education and training. Some professionals, again, might lack that education and training piece to effectively use these new technologies, which is very natural because there's really rapid progress in the development of new technologies. So the key here is having that openness to learning about these technologies, which then helps understand their capabilities and find opportunities in health and safety. Content development, developing high quality content, for example, for extended reality type of applications, sometimes can be challenging, especially if you're focusing on a specialized area. Data security and privacy concerns that I touched on sometimes can be an additional barrier because really gets people concerned about collecting, storing, transferring data as well. User acceptance and adoption. A good example is with some of the VR applications, some users feel motion sickness or other type of discomfort. And we had that as part of our pilot, that some were okay with using it for a long time, but some wouldn't be able to. So again, you have to be aware and you have to be careful and design the adoption so it's for limited time as well. So overall, I believe although health and safety might be a bit behind in adopting emerging technologies, I think there's a lot of opportunities. And I think as a profession, it can be really used and it can bring a lot of advancements. So thank you very much. I know that was kind of a quick overview of a couple of technologies. You can see my email.